Consider the matrix M equals to 1 0 0 0 0 minus 1 and 0 minus 1 0. A three-dimensional basis formed by eigenvectors of the matrix M is, and four options are given, A, B, C and D. This problem came in TIFR Physics Ph.D. entrance examination 2011. So we have to identify the set that represents a three-dimensional basis and also eigenvectors of the matrix M. You can pause this video and give it a try. So we are going to solve this problem in two steps. In step 1, we have to use the property that if three vectors form a three-dimensional basis, then they must be linearly independent. So let's consider these three vectors represented by these column matrices A1, A2, A3, B1, B2, B3 and C1, C2, C3. Now to check whether these vectors are linearly independent or not, we have to calculate the determinant of the following matrix. Now if the determinant of this matrix is equals to 0, then we can say that the vectors are linearly dependent, and if it is not equals to 0, then we can say that the three column vectors are linearly independent. So now let's go back to our problem. So first let us calculate the determinant of the matrix formed by the column vectors given in option A. So if you calculate this determinant, then you will find that its determinant is 0. Therefore we can say that all the vectors given in option A are linearly dependent. Now for option B, if you calculate its determinant, then you will find it is not equals to 0. So we can say that the vectors are linearly independent. So this could be the possible answer, but we have to check it for other options. For option C, the determinant is equals to 0. So they are linearly dependent. So option C cannot be the correct answer. Now for our last option, option D, if you calculate its determinant, then you will find that it is also not equals to 0. Therefore, we can say that option B and option D could be possible answer. Now in step 2, we have to check between these two sets given in option B and option D, which set represents the eigenvectors of the given matrix M. So if lambda is the eigenvector of the matrix M, then it should satisfy this relation. Here lambda in the angular bracket represents a column vector, and this lambda is any scalar, or you can say that this is the eigenvalue of the matrix M corresponding to the eigenvector lambda. So first let us check it for the set given in option B. So if you operate the matrix M on each column vectors given in option B, then you will find that they represents eigenvectors of the matrix A corresponding to the eigenvalues 1, minus 1 and 1. Now for option D, if you perform the same thing, that is if you operate the matrix M on the sets given in option D, then you will find that the last one doesn't represent an eigenvector of the matrix M. Therefore we can say that the option B is the correct answer.